All right, hello everybody. Hopefully everybody can hear me. Eric, if if you can't, let me know. But thanks for joining this webinar today. It's going to be a fairly quick one. Really not a whole bunch we're going to do. Just kind of a little powerful feature inside of Mastercam called Process Hole. Those of you that don't know me, my name is Justin Patterson. I've been with QTE for about 8 years now. I'm actually based in Wichita, Kansas, so I know quite a few guys around here. So with that, I'll go ahead and get started. Let me share my screen. 1 second. All right, so you should be able to see my screen right here, hopefully. Okay, so to go down what Process Hole is, Process Hole came out a couple releases ago, and it's a fairly unknown feature that I think is extremely powerful, especially if you find yourselves doing several series of holes all the time. I'm always doing this type of hole in most all my parts, whatever it is. Now, it is still pretty fast to put holes in the traditional way, going and just selecting your holes. Like, let's say we're looking at this part right here. Just going and selecting your holes is still pretty fast. But this is where Process Hole is going to speed this process up even more and make it a lot more efficient. So what's really kind of cool about this is you just build yourself a template. Okay, so I've kind of thrown this template together. And I'll go ahead and preface this right now. If any of you guys want this template as a good starting ground, please let me know. Just shoot me a message into support@qtemfg.com, and I'll gladly send you this file. Because this is the stuff that kind of takes the most work, is setting this up. So what you want to do is you want to build a template for each hole type. So I have simple holes, I have blind holes, and through holes. And as you can see, I've grouped the levels together, and I've also grouped them in the solids manager here. Same thing with tapped holes, thread mill holes, counterbores, so on and so forth. I have the blind version and the through version. Okay, the reason I did tapped holes and thread mills is just as simple. Am I running a tap in it? Am I running a thread mill in it? So what you'll want to do is you actually want to create that hole there that matches. So like our half 13, which is what we're getting ready to do. I've kind of went in through and changed these up a little bit. This is you'll do throughout the process of creating these holes. So I don't suggest sitting down and programming every one of these unless you have time, have nothing better to do. But I just kind of do it as I go when I find myself, hey, I'm always putting this half 13 tapped hole in. I'm going to go ahead and do that right now. So it's all going off what the hole's defined as the solid hole. Okay. So as you can see, I have it defined as a threaded hole, right-handed. And I kind of made it a user defined as a 42188 because that's what you're going to drill the hole with. That's when I model any of those type of holes. If I want this to be an actual tapped hole with a regular tap, that's what I'm going to model that hole in. But if we go here to like a thread milled hole, okay, in a half, it actually got rid of my name. See, we can go in here, we can rename this. So let's say instead of simple, it's actually just a half 13 thread milled hole, right? Okay, so we can name it whatever we want, and then I defined it as a 429 because that's what I'm going to go for my minor on my pitch. This is the work, is you just need to know what you're actually defining these holes as. So this is what's called your template. So I built this template based on that type of a hole. So in the example of the thread mill hole, that's a half 13 thread milled hole that's in a blind section. So I went in there and really, to do it right, I group them like this. It's the 3/4. So obviously I'd want to create another group here to call this the half 13. But it doesn't really matter. This is more organization for you. The process hole function will not, you could have all these in one complete order. It doesn't matter. I just say do this for your organization. Okay. So let's move to this part right here. So I brought this part in as just a dumb solid, meaning all the history's been removed. Those of you guys know me, I always remove the history because I think the model prep functions inside of Mastercam make it so powerful there's no need to bring in history. But one thing for Process Hole to work is you have to have a defined hole. And right now these are not. But in model prep, they have what's called find holes right here. This is really kind of cool. You just pick it and it searches the model. If there's more than one solid, it's going to ask you to pick what solid. But there's the one solid. I like to create a single operation. So instead of like these are our thread milled holes. So instead of having 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 total holes showing up here, it just puts them all in one. Same thing with our counterboard holes. So I go ahead and green check it. Okay. And there it goes. So I found 15 holes from this body, and there they are. They're right here. Okay. But I'm going to define it the way that I want it to be defined. So like prime example is our counterboard holes. If I just double click on this, I can go in here and actually redefine what this exact hole is. Well, it's a socket head cap screw, and it's 3/4 of an inch. Okay. And I'm doing through all. So we go, because this is going to bolt this manifold down. Okay. That's pretty much it. I just defined that as a counterboard socket head cap screw, 3/4 inch diameter. With our simple here. And again, if you don't remember what you did, go back to your actual template, and I go to my thread milled holes. And if I look, oh, it's just a simple, and I did 429 because that's what's going to tie these two together. So here you go. So there, it already did great. It did exactly what I wanted. I'm going down 1 inch. That's fine. But if you want to go down less, you can. All right. So I've defined these two holes, these two different sets of holes. And then for process hole to work, all you need to do is you need to go in here and grab process hole and just grab what holes we want. Now, here's a little preface that I'm going to say, like, let's say we do these counterboards. How you pick it in here determines how you pick it out there. So like if I go to my counterboard holes right here, when I went to drill this hole, I actually picked this surface right here is what I did. So if you notice, it said the 1875. Okay, so that's the same one I'm going to pick when I go into here. So I'm going to hold Control and Shift together. It picks all those holes. And then if you look, it already found it because there's my template. I'm reporting to this template. So this is where I can go point to these different templates. You don't have to have it all in one template like I do here. You can have a template just for counterboard, just for thread mills, just for counter sinks, dowel pins, whatever. It's however you want to do it. You can just go point to that template. Okay. So look, it automatically grabbed it and said, well, that hole you told me, well, that's what you want to do. You want to do a peck drill and a helix bore. You notice I don't have a center drill, and I'll explain that here in 1 second. But see, that's exactly the holes that I defined here, and I green check. And it's going to generate those tool paths just like that. And there it is. There's our process hole. Okay. So it goes in there. It's going to drill all the holes. Okay. One thing you notice is, man, we're crashing right here. Look at this, you see? Because this hole is defined to be a through hole, right? A through hole, and it's looking at the full geometry. Okay, but what's really kind of cool about process hole is I can come in here and make edits to this by coming and saying, hey, let's explode the process hole. And what it does, it creates me to each individual operations. If I need to go in there and make a change for whatever reason, like prime example, this drill is just a silver and dimming drill. Maybe this one's not going to work, this 13/16 drill. Maybe I need to go in there and find something else. So 13/16 drill. We'll just have to find which one. I think we're going to have to probably get pretty creative on finding a drill long enough. But you get kind of what I'm saying. You can go in there and make the changes to this, and it didn't affect anything. I still have my helix bore right there. So let's go do our thread milled holes. So I'm going to go process hole, and I'm going to pick my thread milled holes right here. Control Shift again, select all matching cylinder diameters. And there you go. It already found it because it happens before I can even switch to that tab. It went and searched that template, said you want the peck drill and you want the thread mill. All that information's in there. It loads the tool. I also have the ability to come in here and changing these planes. I can do a minimum height or a set clearance plane all the way across. I'm fine with this. This one works just fine. Just go ahead and green check. And it generates the tool path. Just like that. Pretty simple. So we drill down. And this one, you notice, I don't know if you paid attention, I brought this hole down 1 inch. But the thread mill I'm using is just an ISCAR thread mill. It only has 890 thousandths worth of threads. So when I defined it in my actual template here, so let's go to the thread mill. You're going to notice that I defined this in the linking parameters to only go down 800 thousandths or 850, whatever you want. So it's still going to pull that information. So irregardless of how deep the actual hole is, I kind of limit it. That's more of a safety thing, in my opinion. Is that way this hole was 1 inch. It's not going to try to shove that thread mill down the full 1 inch, just like that. So I think that's pretty quick and easy how it can just throw these holes in. Like I said, you can expand it, create individual operations if you want to look like a rock star. Why I say I don't like to do the spot on there, because I want to do those all individually anyways. I'm sorry, all as one set of holes. So I'm just, whoops, sorry, got a little click happy there. So I'm going to go in here and I'm going to pick these and I'm going to pick these. So again, just control and shift. I can come in here and let's sort this starting right here. Okay, we'll do it in that fashion. And then I'll just spot drill all these as their own instead of, messing with, seeing it loads all our tool. Instead of messing with, it's only spot drilling the counterboard holes and then only spot drilling the thread milled holes. So that's kind of the way I like to go about it. Oops, let's go back to here. Let's bring in our spot drill. Let's say we use this 1/2-inch spot drill. And again, if you don't know, go in here and let's calculate the depth to be actually at the top. We'll use our little calculator here. I know I'm going to come in. Let's make everything 400 thousandths, a little 400 thousandths countersink, so it's over at the depth. There we go. So now we've spot drilled all the holes at one time instead of breaking them out individually, right? Still set the peck. Because remember, it's going to look at the previous toolpath that was there. So let's go here and just put this to standard drill / counterbore. So that's basically on a part. A good example that I think a lot of you could find use into this is I should have went in. I got thinking about right before the webinar started. I made this as like a grid plate, which you typically see on most of your machines. I should have done it for like inverter bolts, because that's kind of a more step process where you've got different features to it. But I kind of did it a little bit like that when I come in here to my dowel pins, because you mold and tool and die makers taught me this. I never knew that, but to actually do a true dowel pin hole, you want to go in there and actually drill it, fairly undersized, interpolate it within like 14 thousandths, and then you can ream it. Well, guess what? I have all that set throughout my template here. Okay, so again, see, I have all these holes. That I've got some blind holes, which these are all going to be in my blind holes. And then right here, so I go to my counter. I got my dowel pin holes right here, and I have my 1/2-inch dowel pin hole. So all I've done is defined it as a dowel pin 1/2-inch. And then over here, there it is in my 1/2-inch. I have my peck, helix bore, and counter bore. Or a drill, which is actually the reaming of the holes. But this, again, I would come in here first before I even started anything and just window everything in. Let's just drill all these holes. Let's spot drill them all. I'm going to do it. You could go in one of these fashions. Let's say you want to go like that. That's the order. You could be a little faster at that, right? So we go there. Again, go pick your spot drill. Takes this 1/2-inch spot drill right here. Same fashion. Calculate from the top. And let's 1/2-inch is perfectly fine to me. That doesn't hurt nobody. 3, let's just use an incremental for now and make you 2, make you 2.5. Okay, looks good. So we went in there and we spot drilled all the holes. Now we can go with our process hole. So process hole, since this one has a lot more features to it, I just control shift select again. And this one, oh, I'm sorry, my help if I put the holes on there. There I go, get ahead of myself. I can practice this all I want, but the minute I get in front of people, I find a way to screw everything up. But it's processing. This is such, all this whole data kind of takes forever. So bear with me on this. We do need to go in and create the hole, because remember, it's just a dumb solid. I don't know why this one has to take forever. Bear with me. Come on. Probably almost faster. Let's just start a new session and see who wins. Yeah, just so you know, you guys aren't the only ones that fight these battles here, right? Oh, see, right there, that one won. We'll just leave it open still. Okay, so I go here again. We're going to go here to model prep, find holes, create as a single operation. Sure, boom, there it is. And it's creating all our holes. There it is. And I have a simple 500 where that is my actual dowel pin hole. So it's a simple. I'm going to use the light. So right now I can do it as a user defined, or actually go look at the library, say, hey, let's go use a dowel pin hole. It's a 1/2-inch dowel pin hole. Sure. There it is. Reach in. And that's probably going to screw me up again. We need to go get rid of this. So see this one, it already populates. So we just delete that. Sure you want to? Yes, I want to proceed. There we go. Okay. Go back into here, go back into our solids. I'm working my computer today, it sure seems like. And then here, I'd go in here, and again, if you always need to reference, what you have it set to here, which I actually have this hole. It's going to be right here. And again, this is why grouping is so nice. See this? I have these all individual. This is a 2026 thing, if you're not familiar with that. See, I've got all the blind holes grouped together. And then what's really cool, if like you go look at it, it tells you what's all in there. There's some lines, there's some solids, and there's a spline, okay? But back to this, I go to my tapped hole, I go to my half 13, and it's a threaded half 13 is what I have it named. Man, it's just, my computer does not like me today. Double click, maybe I didn't, might help if I actually double clicked on it. Come on. I don't know why my hole's not coming up. Story of my life. I think I made it angry, but I know I did it as a threaded 4219, 42188, and it's a right-handed thread. I just remember that. I was just going to go back and show you. Let's go here. Let's green check that. And there we go. We're here. We regenerate that. Okay, then to your process hole, you can always hit save right before. And then it's saying updating toolpath. This file does not like me this morning. Oh, it's because I have that still open. That might help. There you go. While this is working, as you can see it's right-handed 42188 is what I have that half threaded half 13 bolt done as. It's still thinking. There we go. Go to our process hole. Control Shift Select. It selects all of those holes. And there you go. It pulls it directly from there. There's our PEC. There's our rigid tap. I green check. It's going to generate. Obviously, it's going to take a while. Just because that's the way Karma likes to work for me. Okay, we have those holes done. I just jump right over here to Process Hole. Control Shift Select. Select these holes. And make sure our dowel pins are correct. Just delete all these. See, like I said, go over here and make sure that what you have it defined as is correct. If you do this a lot, it's really not a big problem. But as you can see, I don't do it enough to even see. I have it as that should be simple dowel, ½ inch. That's what everything's driving off of. This file does not like me one bit. No, I do not want to keep you. Solids. Okay, those are all those. So let's go in here. Simple dowel. We could do user defined library, simple dowel. There's a half 13 blind. There you go. And sometimes if you run into problems, it could be just your template needs to be reloaded. Okay, so we're going to come in here. And if you want to be a little faster at it, just do one at a time. Okay, so let's go pick off of our template. Make sure our template is saved. Okay, and reload our template. There you go. So I just needed to reload my template because it could have been when I was actually saving it. But there's our 3 hole sizes right there. I have my PEC, my helix bore, and my drill. And it's going to create that. And again, I'm doing the one right now because right now there's something weird with this file that doesn't like me. It should not take this long. When I was creating this file, it definitely didn't take that long, but it's just the nature of the way it works for me. So there's our drill to go all the way down. There's our circle mill. Same thing. Look at that. Okay, well, that's not good. So I need to come in with a different tool. Well, you don't even have to create that because I could go to my tool library and make the change right here. Because see, it gives me all this stuff. So I can go find this flat end mill right here and then look at our actual stick out. Say, hey, this one's not going to work. Maybe I need to go find a longer tool, whatever that case is, right? You still have all those options. all that same thing's going to work. So then we go in here. It's now got that new drill, or that new, I pulled that holder up to where now we have all the room we need. So I was kind of little cattywampus there when stuff doesn't want to quite cooperate with me. It's just the story of my life. Really, it all comes down to creating these templates and knowing what you're defining these holes. Again, now this is not something that I'm going to find extremely useful on holes you do once every 7 months. It's not beneficial. It's on these series of holes where a good example is I worked with a customer about 6 months ago that had these fixture plates where they were called, I forgot what they were actually called, but all the fixture plates bolted to this big plate. And they'd have hundreds and hundreds of these holes that would be all very similar. They'd be dowel pin holes or threaded holes, and it took forever. And I helped them build a template for it. And literally their programming, what was taking them a couple hours doing all this, they were doing in under 10 minutes because they were always putting in these threaded holes. They were always putting in these counterbolt holes. They were always doing this, that. And so if you don't want to build a template this exotic to where it has all of this stuff, just build it big enough to do what you're doing. You know, if I only want some half 13s in there, I only want a half inch socket head cap screw. And all you do is you just build the hole, make sure it's defined the way you want and the way you're going to know it, and put the toolpath on it. Just pick that hole. Okay, you just go and pick the hole that you're going to cut. And that's what happens is when you go and pick process hole, it looks at what the solid hole is defined as, and it looks at this template, said, okay, well, you told me to do it this way. Boom, that's the stuff I'm going to put in there. So you could see, you could even have different templates. You could have a template file for just blind holes that are threaded holes. You know, you have one for countersinks, you know, so on and so forth. You don't have to have it this elaborate. It's kind of however you want to go about it. But hopefully this was informative for you guys. If you have any more questions about this, if it's something's just not making sense, or you want to try it on your stuff in particular, give us a shout at support. Again, the email address is support@qtemfg.com, and we're definitely here to help you. Doesn't look like we have any questions, but yeah, if you guys need anything, please let me know.